Okay, this is lesson 7.3. I want to point out that the formula we've been using for confidence intervals is this one. When you know your population standard deviation, or when you know your population standard deviation but your sample size is greater than or equal to 30, then you use the standard normal distribution. You use z-scores. And you can see we have a z-score here and a z-score here in our formula. Now, of course, if you know the standard deviation of the population, go ahead and use that right there. But you notice here that it says if n is greater than or equal to 30, and you don't know the population standard deviation, you can use S instead. S is the sample standard deviation. So you can use the sample standard deviation in place of the population standard deviation when n is greater than or equal to 30. Now, what if you don't have 30? What if you have a sample size less than 30 and you don't know the population standard deviation? Then you use what's called a t-distribution. A little bit different. Instead of a z-score, we're going to use a t-score. Since we're less than 30, we're going to use S. Well, this formula is only used when you have a sample size less than 30. So we're going to use S. You can only use S up here if n is greater than or equal to 30. So hopefully you can kind of see the difference here. Now, number 5. Better read the problem here. The average hemoglobin reading for a sample of 20 teachers was 16 grams per 100 milliliters, with a sample standard deviation of 2 grams. Find the 99% confidence interval of the true mean. So let's write down some information here. 99% confident. Most of the time in medicine, we want to be pretty confident, okay, because there are, bad result. Something bad could happen if we're wrong. So we want to be pretty confident. So we normally use a high level of confidence. The sample size is 20 teachers. And the average reading was 16 grams. That's our X bar. 16 grams.
How come you don't use like 16 over 100?
Per 100 milliliters? You probably could, but it's just simpler not to use a fraction and just assume that this is the grams out of 100 milliliters.
Okay.
It's simpler to do it this way, I think. Standard deviation of the sample is 2. So that's S, 2 grams. Now the first thing you have to do is figure out the degrees of freedom. Degrees of freedom is n minus 1. So 20 minus 1 would be 19. Then you go to your t-distribution chart, which is on the back of your z-distribution chart. So if you haven't noticed that, on the back of your z-distribution chart is a t-distribution chart. And up at the top, it should say confidence intervals. And you go all the way over to the right side where it says 99% confidence. And over here you'll see a DF for degrees of freedom. You go down until you find 19. And you come over, and you come down from 99%. And your T-score, instead of a Z-score, should be given right here. And I'm going to grab my notes again. According to my notes, and you can check to see if you agree, I have 2.861. Sound right? Okay. So now it's a matter of just plugging into the formula up there. So I take X bar, which is 16, plus or minus my T-score, which is 2.861, times S, which is 2, over the square root of n, so square root of 20. So first I would do 2.861 times 2 over the square root of 20. Someone tell me what that comes out to. 2.861 times 2 divided by the square root of 20.
1.27.
Give me 3 decimals.
279.
279. Okay. So that 1.279 is that's our maximum error of the estimate. So now we're going to do 16 minus 1.279, which would be 14.721, I think. then do 16 plus 1.279, that's gonna be 17.279, let me check that with my notes. Then how does it say to round it? If these are in whole numbers, what should I do with these numbers? Whole numbers, yeah. So 14.7 would round to 15, 17.279 would round to 17, and the average has to be somewhere between there. Oops, between 15 and 17. So we're 99% confident that the true average of all teachers is somewhere between 15 and 17. I want to back up and answer your question again, Laura, because I think I can do a better job at answering it. Since our standard deviation was in grams, our mean should be in grams also. You got to make sure you use the same labels there.
Okay.
Okay. Any other questions?
So it's not like 0.16 or I just,
No. Because if you put 0.16, that'd be in grams per milliliter, and then you have a different label here. You want to make sure that your mean and your standard deviation are in the same label.
okay,
I don't think you have to worry about that very often, but in this problem that does come into play.
okay.
All right, I'd say go ahead and try the assignment, and if you need help, let me know.